Go ahead, you got it. I forgot any stuff. How many start streaming?
Yeah.
Ah, no.
Go to OBS and then start streaming from there.
Uh, what?
And then select existing
Oh,
broadcast
oh,
and then tap
what
on
is the
it, and
hell?
then yeah, I think you should be good to go.
Ah, crap. God, just a second. I messed that one up. I need to delete this.
Um, yeah, I can see on live now. You can go ahead and get started.
Just a second.
Okay.
I need to. Uh, okay. I need to delete this. Uh, so back to this.
Yeah.
So, got it.
Okay. Um,
Another answer.
I can start today actually. Can do the introduction today.
Hello guys, welcome to my YouTube channel. So today I'm joined by James, and we have something for you. Why about variable lifting or hoisting? Um, so we're gonna take a look at some pretty interesting examples, and hope you'll get to learn something and you'll get to enjoy. So James, you can take us through what we have today.
Okay, thank you, Michael. Good morning, good evening from wherever you're watching, or good afternoon from wherever you're watching. So today we have a very interesting topic to discuss about something that someone can overlook, but if you didn't know it, it might actually be a problem at the end, at the long run. An example of it will be this is what we call hoisting. This means that you are trying to access a variable before it's even declared. If I can make it as simple as that. Or if you're when you're trying to access that variable, you might get undefined, or that programming language might actually allow you to access that. That's something that you can actually find in, let's say, Python, JavaScript, and as well as PHP. Those are the languages that I've interacted with that I've seen have that particular problem. An example will be in this code I'm using Python right now, and I have this array. We started from 2 going onwards up to 10, and then I'm doing a loop within that array, and then I'm checking if the value that I am looping at that index, so if it's divisible by 2, meaning that's an even number. So if it's an even number, then I'm assigning x to taking the value of I, and then I'm multiplying it by 10. So x is equals to the value of I times 10. But Once I run each code, once I run this code, yes, I'm getting the value of x, printed x, and also printed the value of I. The first time it's supposed to run, it's supposed to print 2, 2 times 10, that will be 20. On the next line, that will be 3. I'm still seeing the value of the previous um, loop. So I'm still getting the 20. If you look at 4, I'm getting 40. I'm getting on 5, I'm getting also 40, 60, so on and so on. If you're not careful with this one, it might be an issue. Because if you're doing an if statement and then you're assigning that value on that loop, and the next loop you don't need that value, or you need it to be something else, then you might end up actually having errors on your code. Not even errors, you might actually be showing the wrong data to the client or saving that data to wherever you're supposed to save that. So this is an example that is happening across so many languages, and then at the end of this stream we'll try and show you how we can solve such problems or a workaround for this. But before I get there, I'll let Michael to take us through the same perspective from a low language if it actually exists.
All right. Thank you, James. So I'll just open our C++ project here. So I've already written the example down. Exact same thing. So we have an array here. I've declared an array of integers. Then I'm looping through this array,
Mhm.
um, multiplying its value by 10 and assigning to x, our integer here. Then we're trying to print it. So already you can see that we have a red line here. So the IntelliSense is telling us that this x is undefined, and even if you try to run it, you'll see that it will tell us there's an error. It cannot build because there's an error that is occurring. So this is one of the great things about low-level languages. They will tell you there's an issue right before it even occurs, and the way it works is um, you cannot use memory time. And when you're dealing with low-level languages, specifically C++,
Mhm.
when when it is compiling, so there's compilation before it runs. So compiling is basically turning your code into binary, something that can be run by the operating system that you have. So there must be compiling first before uh, before it tries to run it. So this error occurs at compile time. So it's a compile time error, and it basically tells us that you have a variable that is undefined at this particular position. And this is definitely because we have the aspect of scope.
Mhm.
So scope is basically um, within. Okay, let me explain it in terms of C++. Anytime you have these curly braces, you have a specific scope. Or so, for example, if you declare a function, then everything that is declared within the curly braces of that function will be within the scope of the function, right?
Yeah.
So the scope can work for the function, it can work for loops, it can even work for uh, what is called the conditions. Yes, the conditions. So, for example, here when we enter, we have this my array, which will be available throughout the scope of this function. A.
Mhm.
We have this for loop in which we declare I. So
Mhm.
this I will only be available to the scope of the for loop. Even if I try to access I here, let's say I try to just print I at the end of the loop, again, you see that uh, the IntelliSense is complaining that this is not within scope. There's nothing that has been defined as I within the scope. Again, so when you come here, it happens the same for this condition. The if We have declared a variable at this point,
Mm-hmm.
assigned it a value. However, we've gone out of this scope and then we're now trying to assess it at this point,
Mm-hmm.
which now, so the question would be what would be the best solution when it comes to using this? Like at what point should we access it, or how should we best declare it such that it is accessible? So, there are a number of ways. Of course, you can always use the global scope. So the global scope is just it's not within any function. It's just declared within the file, which means as long as you have access to the file, you have access to that memory.
Mm-hmm.
So if I put it here, this means it's a global scope, and then I'll make sure to remove this declaration in here because that means we don't declare the place. So if I put it on a global scope, you see our error goes away because it's available to us again. Still, I can put it within this function
Um,
because it is still within scope.
I have a question.
Yes?
So if you put it, if
Yeah.
you declare your X at at the start of your code, meaning that you're making it a global variable, doesn't that mean it's
Yeah.
in some instance you're creating another kind of a scenario of hoisting? Because if you look at the next, you're doing an if statement, and then you're assigning X to the value of my array times 10. So if going back
Yeah.
to the example you showed, so it will be 20 the first time, and then the second time X will not be reassigned again. So it's still X will still remain 20. Isn't that not creating another the same issue that we have? Or that's my idea. That's
Oh,
my
yeah, I
thoughts.
understand.
Yeah.
Yeah, I understand the question. Um, so now at this point, it will depend on what the developer is trying to do.
Mm-hmm.
So if for example, you're okay with replacing this value, like you're only using it, like I said, let me just return it here. So at this point, the idea when you are putting it here is you want to use it only once in the within the scope.
Mm-hmm.
You don't want to access this variable outside. You want to use it within scope, and you want it to be declared every time that you're within the meaning it's a new variable every time.
Mm-hmm.
When we enter this if condition, we are creating this variable, and immediately we exit this
Yeah, the
condition.
scope. Yeah.
That variable, yeah, destroy this removed from memory. Um, uh, for this case, it's there's something called stack allocation in memory. So usually when you're declaring tools such as this, there's another type of memory called heap memory, because I think that's something that we can go directly into maybe in another video. So in this case, when you declare things in the stack, immediately they come out of scope, they're removed from the stack. So it's just like a block that you're putting in. So you put in a variable, immediately it's not being used, you remove it from that stack again. Um,
Okay.
so in this case, this is only when you want to use it within this scope. That's the only time that you'd use it. So if in the example that you're saying now, so let's say this, where we have declared it globally, again,
Mm-hmm.
it can be another issue, just like you stated, but it also depends on the use case. So personally, I wouldn't like to do anything like this unless I have really declaring it in a global scope, because every variable that you declare definitely has a use case.
Yeah.
There's a reason why you're creating it here. So if you're declaring it that scope, yet your only use is within this scope, then of course you're creating another problem where you have a variable that is accessible where it should not be accessible.
Mm-hmm.
And that's the other problem which you have stated.
Mm-hmm.
which is correct. So now it depends on the use case.
Yeah.
You should declare variable only where you need it. Um, yeah. So there's also I hope that answers the question.
Yeah, that does. At least for me, it does.
Uh, Great. So in this case here again, so I was explaining this section where we declared it here. So it's inside the function. Still, the function is within. Sorry, the variable will still be within scope since
Mm-hmm.
every time that we're trying to access it, it's accessible uh, within the scope. Still, we can place it here again. Um, it is still accessible within scope because
Mm-hmm.
our scope is this loop. So we've declared it here. We are accessing it within uh, this if statement, but still remember this if statement is within the for loop scope. So
Scopia. Oh
it
yeah.
is we are able to access it. And then
Mm.
at this point we also have this. We are also trying to access this variable. So at this point you can see we also have there's another issue that can arise.
Mm-hmm.
Um, so um, maybe I can go back to the example that you showed in Python so that I can come back to explain this better. So so can you go back to the example that you showed in Python?
Okay, just a minute. Um, so there it is.
Yes, great. So as you can see here, uh, this has worked first of all. So we'll come back to why it has worked in the first place.
Mm-hmm.
But in this case, you see, the first time we have two,
Mm-hmm.
so the value is assigned 2 times 10, 20. Um, then it's printed out the first time. Then we go to three. We have unfortunately three is not an even number, so it will not come to this point.
Yeah.
Oops, my bad. So it will not come to this point where in this loop, I'm sorry, in this condition,
Mm.
which means um, x should not be given a value.
Yeah.
Um, so um, in this case, it's the x is still available. Um, so it is so the value still remains as 20. However, if so, I'll just request add one to the beginning of the array.
That will make it fail because now,
Yes, that should make it fair.
um, now that I did not expect that to happen.
Wow, that
That's
is
weird.
yeah, that is very weird.
Just a minute, I confirm something. Mm, the modular two. Oh, yeah, this one to see because earlier I did run it and um,
It's on.
that's weird.
Really?
What? Hold on. I need to restart this. Think
Yeah.
be- be-
Uh,
because I'm running it on. Yeah, that's what I thought.
oh yeah, yeah. Okay, yeah. It's because it's a little bit of a forget.
Yeah,
So
I
yeah,
was.
we get this issue since now our first condition has failed. That means
Mhm.
we never declare x, and then we end up having this error come about.
Yeah.
Now, if we contrast that with C++, um, so in this case, we've declared this, right?
Mm-hmm.
But we've not assigned it a value,
Yeah.
right?
Yeah.
Um, so if we had started with one,
Mm-hmm.
um, okay, for this one to make a difference, so let me do it first the way we had it before. So if we had started with one,
Mm-hmm.
again, would have the same issue we've gotten. It has not been declared at all.
Yeah.
So So again, we'll get this error. However, there's this scenario where we've 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 declared it within the loop,
Mm-hmm.
right?
Mm-hmm.
So so if we take so in the first instance,
Mm-hmm.
um, we've declared it, but then the condition has failed. Remember,
Mm-hmm.
we've added this one here. The condition has failed. So at this point, when we get to this value, when we try to print the value, unfortunately, we do not have a value that has been assigned because the the condition for assigning this value has failed.
Mm-hmm.
So now this is why we have this green. So remember the previous one highlighted in red.
Yeah.
This one highlights in green
Mm-hmm.
because there's a potential area where we'll have memory that is not initialized. So initializing definitely is assigning a value. So we've
Okay.
declared it, but we've not initialized it.
Mm-hmm.
So if I just a second, I fix this since I did not really to change the size array. So if I try to run this, you see we'll encounter an error. And this is on the, so if I look at the debugging value, so this is at I equals 0,
Mm-hmm.
for which my array at I is value 1. So since it has not come into this condition,
Mm-hmm.
then we have it failing at this point since x has not been given a value.
Okay.
Um, so if I return to the original, um, where we have 2, let me just so we start with 2, which means the first time we'll have the condition going right.
Mm-hmm.
So you'll expect this to work correctly, but if we run it, you'll see that it fails again. So, but this time we
Mm-hmm.
see that I has reached 1, which means the first time it went through the loop,
Mm-hmm.
uh, it went incorrectly. We got um, a value of I, uh, a 0, then a value of x was given as I times 0,
Yeah.
which is 2 times 10, 20.
Mm-hmm.
But then when you reach this point,
Mm-hmm.
now, okay, the first time it prints, then we go to the next loop. So we have 3 as our value,
Mm-hmm.
but then it fails in giving it a value, which means now we don't have a value assigned to it. So it will fail at this point because we have an
Mm-hmm.
initialized value.
Yeah.
Um, so this is the great thing about the low-level languages that you can have this sample happening for us.
Mm-hmm.
That as we compile or even as we debug, it will raise an error immediately
Yeah.
based on whether we have a value assigned to it or not.
Yeah. True.
Um, so now this is something that we need to be careful of. So even in this case, so going back to the question earlier, if we had this X, even in
Mm-hmm.
the global scope,
Mm-hmm.
where it is accessible everywhere,
Mm-hmm.
um, so in this case, if the first time passes through, then it will always have a value. So if we run it,
Mm-hmm.
you can see it runs successfully.
Yeah.
However, if we had a one here,
Mm-hmm.
so that the first condition fails, then this should result in an
That's
oh,
weird.
that's interesting.
Why did he get a zero? So like, or because the declaration of int x, it's already defined. It's a number, so it's already assigned a number by default. Is that what I'm assuming? I don't know.
Uh, there is that possibility.
That's weird.
Yeah, okay. I think since you've declared it in the global scope, it is initialized as
Mm-hmm. With a
for
default
numbers it
value.
will be zero.
Okay.
Yeah, as a default value. So I think in the global scope it works differently, which
Mm-hmm.
means that's also another problem which you have to go for. So for those guys using C++ or other low-level languages, look out for that issue. This one has caught me off guard as well.
Mm-hmm.
Though if you put it in this scope within the function, you can
Mm-hmm.
see that it behaves exactly as expected. It fails on the first instance. Since no value has been assigned to x, then it will, and our condition has failed, so no value has been assigned to x, then it fails.
Okay.
Um, so the question will be, what will be the solution for this? Um, so depending on a scenario, if you need to use x within the entire function, then this would be the solution. However, for our case here,
Mm-hmm.
uh, the right thing would be we only print x within the scope. We only use x within the scope if which it is required.
Yeah.
So here, here's one here. So if you run it, it works. Um, so going back to Python and the reason why it doesn't work. Um, so for low-level languages, we basically manage memory for ourselves.
Mm-hmm.
Uh, as a programmer, you have control over how memory is allocated. Basically, as I said before, when you do this allocation, you are declaring it on the stack. The good thing for us in the stack, the second you get out of scope, it is removed from memory. So whatever value you're using is from memory. You are no longer able to access that point in memory.
Mm-hmm.
However, when you look at Python, so now Python does something interesting. So, and I believe this is for most high-level languages. Um, there's something called garbage collector.
Mm-hmm.
For Python, it is called the garbage collector. So what that means is, instead of you as a developer managing the memory, the garbage collector manages the memory.
Okay.
And how it will do that is, once you declare a variable, it will keep it will keep a reference of that variable until a point where the garbage collector sees that we've used a lot of memory. Now
Mm-hmm.
let's see whether there's any memory that
Not
is
used.
being is not being used. Yeah. So at that point in time, it will remove everything that does not have a reference. Not
Mm-hmm.
having a reference means there's no point where in the code after declaration is it's being used. At that point in the code, it's not being used anymore. Or basically, if it's out of scope, at that point is where it will be removed. So
Okay.
in this case here, so in this case here, uh, so this X is out of scope.
Yeah.
However, since the garbage collector has not done its part to check whether it needs to remove anything from being accessible in memory,
Mm-hmm.
then X is still available for us to use, and that's why we are able to use it as long as you have the first declaration. So now in the example where we had two as the beginning value in our array, then we were able to access it at that point. But then you see this might also bring a challenge where if 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 you do this, maybe it works now, but if you
Mm-hmm.
have an example where maybe the garbage collector does its work before this print statement here,
Mm-hmm.
then you'll get that error.
Yeah.
So it's one of the challenges that comes with high level languages. Um, but I think you discussed earlier you had an interesting sample for us on JavaScript, so maybe we can take a look at that.
Yeah, so generally, based on what you've just said, most of these high-level languages have their own garbage collector, unlike the low-level languages, which you either have to do the memory cleanup for you and assign the memory such things. So, for just before I go to JavaScript, I have another example
Yeah.
on that. This one is mostly used on Flutter, but uh, something similar to what you've done on the low-level languages. Uh, that usually does a pre-check of your code before it even runs. So, example of
Oh,
this,
nice.
I've written the
Okay.
same code that we had on Python on that, and then I've listed all everything on here, and then I've done the loop. But every time I try to print X, already uh, my VS Code is telling me that
Mm,
okay,
yeah.
X is undefined at this point. It doesn't know the value of X. So even if I try to run this
Mhm.
code will not run. It will fail immediately because it already knows that X is within this scope. So it's similar to yours, but it's you have to define the value of X before you even do the loop. So even if I try to do the same thing that you did on there by declaring the value of X before you even use it, same thing over here, you can see that still it's telling me that X could be null, and that
Yeah.
does not like those things, by the way. Does not accept null. So it's either
Mhm.
you give it an initial value, just same thing that you did for it to accept. But this brings down me to the next question. This one will now create the same what do you call it? It will create the same kind of hoisting that we had earlier, because as you can see the output, it has done 20, 20, 40, 40, 60, 60, 80, 80, so on and so on. So it's kind of repeating the same issue that I was mentioning earlier. Before now we go to
Yeah.
to the solution of it, we can look at JavaScript and see
So,
what kind
um,
of, sorry.
mm, was a question on that.
Hmm.
Um, it is a about that.
To this, okay.
Um, yes. So in if you do what is it? So if you don't give the value of zero, will it try to run?
It
Yeah.
will run.
On
Already can see it's already yelling at me that this won't work. Like it knows, say, build errors exist in your project. Do you want to let's try and run. Already it has complained because it knows it won't run at all.
that's a whole new level. I like the way it's able to tell even before you.
Yeah, you
It's very nice.
before you actually create errors on this one has to be an error that you just, as in, it couldn't pick up because it didn't know maybe the data type that was coming. But it's usually very strict on the data type that you assigned it. Even if, like, for example, on this one, you see this array that I've already said, I've already defined that it's a list of integers. So if in between I try and assign what do you call it? A string, it's
Yeah.
already going to yell at me and
Terrible.
it's telling me this cannot, it's not supposed to be here. So it already knows. It's like it's usually analyzing each line of code every time before you even run it. Something similar to TypeScript, but this one is a little bit more strict. That makes more sense.
Yeah, that's really good.
Yeah.
I think this is
Sorry?
the language that produce comfortably. I think it's one of the high level languages that I produce comfortably
Yeah,
because
yeah.
it obeys the law. Right,
Yeah.
let's
Okay. So in JavaScript, how you recreate that problem is by using this var. In JavaScript, you usually have, you can declare a variable using three, how do we call them? A lack of a better word. So you can use const, let, or var in either of these three. So const means that that variable will not change at all. So you're not expecting it to change in between the life cycle of that your code. Let means you can change it in between. So you can declare a variable let at the top, and then in between somewhere you can change that value. Var means that now the issue that you're talking about. So, for example, on this code that we have on here, I did the same thing, but since this time I used var. But if I try and run this code, which is already running, I'm still getting the same issue. So I have 20, 20, 40, 40, 60, 60. same exact error, meaning that this value already has something before it even runs. Even and this is even worse if I try and do this. If I actually add the one before
You
before
see,
I'm getting
you
undefined
just
and
get
then
an undefined string.
yeah. So this is even a bigger problem because for me, I don't understand why someone will ever want to use var over maybe const or let. Please, someone let me know because it's very risky for me to use that. So I'd rather use something that I'm sure of what I'll get at the end of it because I don't want any errors at the end of it. Um, so if I try to use the other these declarations that do not accept hoisting, and then, for example, if I try to use let and then I save my code, the code already fails because of the initial one at the
No,
start. So it's telling me X is not defined. But if I remove that, uh, isn't actually checks in it. Oh yeah, because it's out of the scope. So it's never like gets
yeah,
redeclared again, even despite
yeah,
using.
true. So
This is more interesting. Unlike the other
wait, so
languages.
has it printed the first
No,
value of two?
no, because it's not within the scope.
No, not at all. Okay. So yeah, this is more familiar. So this is like C++, basically using let.
Yeah. What about if I do the only challenge now comes when I do this. If I declare no, that one will still give me the same issue. But if I do it here, then I give it X, so it will print this time. And then
Yeah, okay, so
if I do
uh,
that, I'll get undefined. If I add the one before. Okay.
define.
Um, um, So back to this, if I do try to do with a constant, but then let me ask, in the language, do you usually have const in there, the same like reference that I have on here, that I cannot
Yes,
redeclare
yes,
this?
yes, it is.
Hmm. Which variable is that? Like, what do you have to write
Yes,
before? So this one, I'm also getting the
it's
same
const.
thing.
It's basically. Oh, wait. Uh,
It behaves the same as let,
why?
but for const, if I did, for example, if I take this one here up top and then I say x is equals to that, and then I do that, it's going to yell because I cannot really create that variable.
Okay.
Yeah.
Okay.
Uh,
I just want to try an experiment here. If
mm,
um
mhm.
this return comes to within the if
Okay.
function,
Hmm.
the if condition,
Yeah.
and then the console log within to put it within the if. So I'm just curious to know whether um it will allow. Okay.
Yeah, that will
Yeah.
run.
So which basically means basically means const is within,
The scope.
since you can't redeclare it again, it is within that scope. Yeah,
Yeah.
makes sense.
Um, so generally, okay, for just to maybe to bring the same thing on that, we should usually use the word final before declaring the variable. So that means that I'm not going to change that variable in between. So if I do see the way I've done this integer and then I've given it to x. So that is the same as using let in JavaScript. But if I was to write it, I was to
Uh-huh.
start with the final, I'm saying that that variable is not changing at all. That's how it will
Yeah.
be within the life cycle of it. Back to
Okay.
now to the solution. Always make sure that if, especially in Python, either you either do this at the point where you're you're running it, you either declare it as you say X is none before you actually do your checks. So that if you're not sure about the value of X, you can always do if X
Okay.
uh, is
I can
not,
always do a check.
yeah, and then you can continue. Now that one will always work perfectly with that. Now you see, I get the perfect answer. Just because at each loop I
Yeah.
specify that X is going to be null, none, gyro. And then after I did my check,
Yes.
just print in the correct thing now.
Good.
Just to prove it, to prove a point, I just do that. And then I run this. Um, I'm getting that now instead of
Value.
this one would have actually failed initially, and then this one will get a 20, 40, 60, 80, so on and so on like that.
Yeah.
So for JavaScript, please, unless you know what you're doing, please avoid using var. Unless you know what you're doing. Unless there is, for whatever reason, you need to know the value of X even before you declare it. This is a good example. Let me just comment it out. Comment what you're just showing. Then, unless there is a reason why you will need to access X before you define it, I don't know. I'm not sure at what point you'll need that, but okay. Or maybe the other reason why someone will actually would want to use the value of the reason why you I mean the other reason why someone would want to use X in such a situation will be, for example, here I would like to print X.
Mm-hmm.
Now that one will work because now this X actually now becomes a global variable outside that scope. That if that makes sense to you. Instead of someone declaring the value of
Mm,
X at initially, at this point, you want it to be initiated in between your
uh-huh.
loop or your function, then you access it later. That's the only scenario
Uh-huh.
I've seen it being useful, but still a risk to play around with it. What if that value becomes undefined, like it was never assigned any value? That code will fail in between.
Yeah. I will say in that example, it will make more sense to like the way they declare x equals none in the loop, you declare x equals none now outside the loop.
Mm,
So that basically you're working with a variable within the like within the scope that you're going to use it. You
yeah,
never
yeah,
declare it outside the scope.
yeah, true, true. Um, But I'm just thinking like for just best practices, just if you know you're going to use a variable outside, like you know you're going to use it somewhere else, don't declare it inside here and then you wait to expect something outside of here. Initialize it first before you try to loop within and then create that variable. Because that is, let me say it's just poor
Exactly.
practice. That's my
Yeah,
opinion.
I agree with you.
I think
I
that's
do
it.
agree with that.
We've explained that and why you should avoid it and what you should do to not create such scenarios.
Yeah.
Maybe if you have anything else before we close.
No, not really. Um, oh, yeah, I remembered something. So last time we had done something on converting bit numbers.
Mm-hmm.
Um, so perhaps there was a time that we were calculating 0.1 and we didn't get it going right.
Yeah.
So I took a look at it and maybe I can just show what was the right way to do that calculation
Okay.
so that we can get our views getting the right thing. We'll also put the link on the description below so that you can go back to the video in case you missed it.
Mm-hmm.
So
Mm-hmm.
let's go back to Let's comment this out. So this is what we had last time.
Mm-hmm.
So I'll just comment this out because this is something I added later. This is something I've added later. So this is what we had last time.
Mm-hmm.
Now, I tried to look at what we had done, found that this wasn't as accurate as I wanted it to be.
Mm-hmm.
So this is the better way of checking that. Um, just read this comment. So there's this declaration here.
Yeah.
So this is a union. I don't know. I don't know if high level languages have unions. I've never used it.
I think I've seen it on TypeScript,
So
if
just
I'm not wrong.
oh, that's nice. So basically, what it does, what a union does is it allows us to access certain place in memory
Mm-hmm.
as as different types,
Okay,
if that
okay.
makes sense.
Yeah.
So, for example, if you're declaring a float,
Mm-hmm.
so we have a float value. So a float is 32 bits, right?
Mm-hmm.
So on those 32 bits, so definitely we know that they're stored as
Mm-hmm.
so um, which means ones and zeros. So if we can be able to put a union on another, if you have a float which is 32 bit, then we can also declare it as another 32-bit value.
Mm-hmm.
I hope that makes sense.
Yeah, yeah, it
So
does.
int is also 32.
Yeah.
So in this case, we are trying to it access this memory as both a float and as an integer. And then when accessing it as a float, we call it a float. When accessing it as an integer, we call it.
Mm-hmm.
So now here I've declared it. So I call it number. So I've declared it as a number,
Mm-hmm.
given it the value now. Then I put the value now x float equals 0.1 uh,
Mm-hmm.
float value.
Mm-hmm.
Right? So now I'll be able to access. So let's do something interesting here. I'll just print this as so you have the x float and I'll just duplicate that so it's easier. And then we have the x int. I'll just comment this out. So if I run this,
Mm-hmm.
um, so you can see this. We have 0.1, but in as an integer, this is the value that we get, um, which it's kind of weird, hard to make sense of. But maybe it will make more sense when we do this. So So now in this line, I'm converting this integer that we have here
Mm-hmm.
into uh, into the binary. Basically, I'm trying to look at the binary value. So if I run this,
Mm-hmm.
so we have a binary value.
Mm-hmm. Mm-hmm.
This if I compare it with what we had last time, and just comment this. So if I compare it to what we had last time, if I comment this out, we'll have this.
Yeah.
So there's a slight difference,
Mm-hmm.
right?
Mm-hmm.
And also, so I think the issue comes with you're trying to separating your character. I'm not really sure, so maybe my source was not the best in getting this code.
Mm-hmm.
However, if now we have our correct value, so we can try and
Mm-hmm.
see whether we can get this in calculation. So I had I had gotten this done.
Mm-hmm.
So just as a recap of what you can do. So we usually calculate it when we are calculating for a float, we multiply by 2, and then we take these values right here from top to bottom. So we
Mm-hmm.
multiply by 2, we get 0.2, again. 0.4, and so on and so on. And then whenever we get, let's say, a 1.6, we'll remove this value and just delete 0.6 and 2.
Mm-hmm.
Now, we usually do this until we get a zero, like the full number is just zero,
Mm-hmm.
or until we start having a loop. It starts repeating itself. So in this case of 0.1, um, so the binary value will come to something like this. So it's repeating. That's why I put the three dots there. So it's 0.0011001100111. It just keeps repeating on and on and on. And then if you remember, um, we have to put this in as in exponential form
Mm-hmm.
so that we can calculate the actual value as is in the what they call the IE 754 standard format,
Mm-hmm.
uh, which the computer uses to store. So here, this so in this case, we will say that our point is here, right?
Mm-hmm.
0.0. So in order to put it in this form, we'll have to move one, two, three, and four spaces.
Mm-hmm.
So that's 2 times e, or so negative 4. So I mean, this can also be substituted for this into the
Mm-hmm.
power of negative 4. And then this is also, I think, if I remember correctly, the mistake here we put positive 4 instead of negative 4,
Yeah.
which, if you remember correctly, it influences our exponent value.
Yeah. Yeah. Yeah.
So going back to the IE format. So the first bit will be assigned bit, 0 for positive, 1 for negative. So since our value is 0.1, we have 0 as the first bit.
Mm-hmm.
Then next we have our exponent. So our exponent will be this, the power that we got here, negative 4.
Mm-hmm.
And then we add it to what we call the bias.
Mm-hmm.
So the bias is just, for this case, is 2 to the power of 8, right?
Mm-hmm.
That's 127. All
Mm-hmm.
right. So we add that and then you get 123.
Mm-hmm.
And when you convert 123 to binary, you get this. So since this is not 8 bits, we make sure it is 8 bits by adding a 0 in front of it. So we have this
Okay.
value.
Okay. Okay.
Let me
Mm-hmm.
just put a separator. So yeah. So then next we have the mantissa. So the mantissa is basically this value. So one other thing that we got wrong last time is the mantissa in this case, when you're looking at this value, the mantissa will be everything after the decimal point.
Yeah.
So we will not include this one. So this is our mantissa here.
Mm-hmm.
So if you move the mantissa here, this is our mantissa. So now our IEEE standard format is the sign bit now, then the exponent, and then our mantissa here. So if we try to compare it with the value that we got here, let me just copy and paste it here, and then take this and put and paste it here, and remove the spaces. You can see it's an example
Yeah.
of
Except for
what
the
we have.
last number. The last number is only different. I think they rounded it off or something like that.
Yeah, there's a possibility. So
Mm.
that's now where we have the errors coming in, where it's trying to be as accurate as possible by getting it closer to it,
Yeah. Yeah.
right?
Yeah.
So at least now we have now it makes more sense.
Yeah. It does. Yeah.
Last time we had a bit of question, yeah. So it's still the same issue, but now we know how the computer stores those float values uh, on the on it. Yeah.
Mm.
Uh, yeah, that's it. That's what I had for that.
Mm-hmm.
Yeah. So I think that concludes that for today.
Yeah. So, thank you
Mhm.
guys for joining us. Please ensure you can always catch us up every Wednesday around the same time for 1 hour. We discuss about the various issues, or you get to learn something new with us as well. Because every time when it comes to coding, you never stop learning. That's something that we all need to understand. Even if you have 10 years of experience or 5 or 2, we all always go to back to Google to check for something that we thought we knew, or every time we write a new code, usually, I didn't know that. That's very interesting. So come join us and let's discover new stuff with us. So thank you so much and see you in the next episode.
Yeah, see you guys. See you next